Alright, in this video we're going to talk about one of the most important concepts in trigonometry, and that is the 6 trig functions, or trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. Okay? So these are how they're written and said, and then these are the abbreviations: sin, cos, tan, etc. Okay? Alright, sine, cosine, tangent, they're all functions that deal with angles. Right? Now these angles can actually be obtuse, or they can be bigger than 360 degrees, but to start, the easiest way to memorize these definitions is to think about a right triangle. Okay? So if we look at a right triangle like I have drawn right here, again this is a 90-degree angle because of the square right here. We're going to be talking about first taking sine or cosine of this acute angle theta. Okay? Now the three sides on this triangle, the opposite side to the right triangle, or the right angle, is called the hypotenuse, and that's a term you might have learned in geometry. And then the two other sides are either opposite of that angle theta or adjacent, or next to that angle theta. Right? To memorize the first three major trig functions, what we use is the mnemonic SO, CA, TOA. This tells us about these first three trig functions. The S stands for sine, the C stands for cosine, and the T stands for tangent. And then sine is opposite hypotenuse, so opposite over the hypotenuse side. And these are all ratios, so sine is opposite over hypotenuse. Whereas cosine is adjacent over hypotenuse, from the CA. Okay? And the TOA tells us the tangent is opposite over adjacent. Right. To get the remaining three trig functions, what we're going to do is use reciprocal identities. These are things that you really need to know, really need to memorize for the rest of this class. So cosecant is 1 over sine. Okay? And taking 1 over sine is a fraction, opposite over hypotenuse, and taking 1 over a fraction is going to flip this fraction upside down. So we're going to get hypotenuse over opposite. Okay? Secant is 1 over cosine. Okay? So it's going to flip cosine upside down, hypotenuse over adjacent. And cotangent is 1 over tangent. So it's going to flip tangent upside down, adjacent over opposite. Okay. Alright, so the next thing we're going to do is take this into standard position on the xy plane. And this is going to allow us to move beyond right triangles and just deal with coordinates x's and y's. Okay. So if you remember, standard position starts us off on the positive x-axis and rotates counterclockwise. So here's an angle in standard position. Again, I'm drawing it as an acute angle to start so we can use the previous definitions that we had. Right? So for this angle theta, okay, the opposite side is y, the adjacent side is x, and the hypotenuse I'm going to call r for radius. Okay? We can use Pythagorean's formula, x squared plus y squared is equal to r squared, okay? Again, because this is a right triangle, okay? And be able to figure out what r is given any x and y. All right. So according to this picture, sine of theta is going to be opposite y over hypotenuse r. So let me write this one first time, opposite over hypotenuse. Okay? So we get y over r. Okay? Cosine is adjacent over hypotenuse. Okay, so this is going to be x over r. Again, looking at the picture, what's adjacent to that angle theta. Okay, following along this, tangent is opposite over adjacent. Okay, and looking at the picture, opposite is y, adjacent is x. Okay, now cosecant is 1 over sine, so that's going to flip sine upside down. We're just going to get r over y. Secant is 1 over cosine, that's going to flip cosine upside down, r over x. And cotangent is going to flip tangent upside down, so x over y. Okay. Now for the last 4 trig functions that I wrote up here, we're dividing by x's and y's. And you can draw angles where x's and y's are zeros, but we don't ever want to divide by 0. So for tangent, we want to make sure x is not equal to 0. And for cosecant, we want to make sure that y is not equal to 0. And similarly here, don't divide by 0. And similarly here, don't divide by 0. Okay? Now for sine and cosine, we don't have to worry about that, because if r was 0, if you drew that, you wouldn't actually have an angle. So that's nothing we need to really talk about. Okay? So these definitions, okay, which you can redraw this picture, okay, so you can redraw this picture with an acute angle, you can quickly come up with these definitions just off of opposite and hypotenuse, will now allow us, if we move over into an obtuse angle, like this, we can still do this with y's, x's, and r's. Okay, so it still works regardless of where we are, but drawing it over here as an acute one helps us use the opposite and the hypotenuses. Okay, so let's look at some examples. Okay. All right, so given this angle theta, okay, which has, again, initial side over here on the positive x-axis, and terminal side ends over here, okay, at negative 5, 12, let's find the 6 different trig functions. Okay. So if we draw this down, we know that now x is equal to negative 5, and y is equal to 12, okay, but we still need to figure out what r is. Okay, so again, we know y is 12, x is equal to negative 5, and r. What's that? Okay. So again, to find r, that's the first thing we're going to do, is we're going to use Pythagorean's formula. That r squared is equal to x squared plus y squared, and then we can just solve for r by taking a square root. Okay. So if we add these numbers up, we're going to get 25 plus 144, or 169. So we now know r is equal to the square root of 169, or 13. Okay, so going back to the previous page, sine of theta is equal to y over r. Okay? So y over r in this case is 12/13. Okay? Cosine of theta is x over r. So in this case, x is negative 5, r is 13. Tangent of theta is y over x. Okay? In this case, y is 12, x is negative 5. Okay? All right, our remaining ones, cosecant, secant, and cotangent, are just going to flip each one of these over. So cosecant is 1 over sine, or the reciprocal of sine. Secant is the reciprocal of cosine, so 13/5, negative. And cotangent is 1 over tangent, or negative 5/12. Again, just flipping tangent upside down. All right, so let's look at another one. This one's a little bit more complicated, but the same idea. Okay. So find the values of all 6 trig functions of theta in standard position with terminal side defined by the line 3x plus 2y is equal to 0, with x greater than or equal to 0. Okay. So first thing I'm going to do is draw this picture, okay, and then try to figure out where this is and try to figure out x and y. Okay. So 3x plus 2y is equal to 0 is a line. The easiest way to draw a line is to plot 2 points. Okay. So what I'm going to do is start off by just plugging in x value and figuring out what y is going to be. So if x is equal to 0, we're going to get y is equal to 0. And this gives us the order point 0, 0. Okay? Then I can choose another x value and figure out what y is there. Now I could choose x is equal to 1, or 2, or 15 if I really wanted to. But what I want to do is try to pick an x value that's actually going to work in this equation up here, so that I don't get any fractions. You don't have to do this, but it's going to make your life a lot easier. So I'm going to choose x is equal to 2. Plug that in. 3 times 2 plus 2y is equal to 0. So 2y is equal to negative 6, or y is equal to negative 3. So that gives us a second point, 2, negative 3. So our line goes through 0, 0, and 2, negative 3. This is what we look like. And remember that these angles are measured from the positive x-axis around counterclockwise this way. So that's our angle theta. Okay? All right, so again, we know that this point is 2, negative 3. So we know what x and y are. And the last thing that we need before we can figure out our trig functions is r. So again, r squared is equal to x squared plus y squared. Okay? or r is equal to the square root of 4 plus 9, or the square root of 13. Okay. So now we can figure out sine of theta, cosine of theta, tangent of theta, etc., just by using our definitions. Y over r, so in this case, negative 3 over the square root of 13. All right, now, we typically don't like to leave square roots in the bottom, so we're going to rationalize. And if you remember to do this, what we're going to do is multiply by the square root of 13 over the square root of 13. We're going to get negative 3 root 13. Okay? And root 13 times root 13 is just 13. So there it is, rationalized. You're going to have to do a lot of this, so you want to get used to doing this operation here. Okay? Cosine of theta is x over r, okay, which is going to be 2 over the square root of 13. And again, rationalize by multiplying by root 13 over root 13. So 2 root 13 over 13. Okay. Tangent of theta is y over x. Okay. Y over x is equal to negative 3 halves. And then again, to get the last ones, we're going to use reciprocals. So cosecant, secant, cotangent. Cosecant is 1 over sine, okay? And I'm going to flip it here before I rationalize. So root 13 over negative 3, okay? Secant of theta, again, I'm going to flip before I rationalize so I don't have to rationalize again. Root 13 over 2. And cotangent, flip tangent upside down, negative 2 thirds. All right. So, important angles that we're going to run into a lot are called the quadrantal angles. Okay, 90 degrees, 180 degrees, 270, and 0 degrees, or 360, whichever one you want to view it. Right? All right, so we call these the quadrantal angles because it breaks our 4 quadrants into, these are the angles that break up our 4 quadrants. So if you remember from algebra, this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Okay. So, to find things like sine of 0, or sine of 90, or sine of 180, sine of 270, all we're going to do is use the y's over x's. Okay? So what we want to do first is just order these points. Okay? Now, I can come out as far as I want, but the easiest way to do this is use a radius of 1, and then this point is going to be 1, 0. Okay? The nice thing about a radius of 1 is then we're dividing by 1, okay? And it makes it really easy to do. Okay? Again, our x, y's here. Whoops, sorry about that. Let me go back. X, y's here are 0, 1. Over here, we're going to get negative 1, 0. And here, we're going to get 0, negative 1. Right? And each one of these cases, I'm using a radius of 1. You can do 2 or 3 or 4 if you want. It's just going to move these points out. But this is the easiest way mathematically to do this. Okay? So again, sine is y over r. Okay? And if you look at y over r in this case, you're going to get 0 over 1. So just 0. Okay? Cosine is x over r. Okay? And x over r is going to be 1 divided by 1, or 1. Okay? Tangent is going to be y over x. Okay. Y over x is going to be 0 over 1, or 0. Okay. And then cosecant, we're going to start to run into some problems. If we look at cosecant, it's the reciprocal of sine. So 1 over 0. Okay. 1 over 0 is not defined, so what we're going to say for this one is that this one is UND, or undefined. Okay. Anytime you divide by 0, you're going to be undefined. Okay. Secant is 1 over cosine. So 1 over 1, or 1. And cotangent is 1 over tangent, 1 over 0. So again, undefined. Okay. All right, we can do this similarly all the way around. Let's do one more. Let's do 270, and you guys can fill in the rest if you want. Right? So sine of 270, again, is y, negative 1, over r. R is 1, so it's just equal to negative 1. Right? Cosine of 270 is x over r, so 0 over 1, or 0. Tangent of 270 is y over x, so negative 1 over 0, undefined. Okay. Cosecant is 1 over sine, so 1 over negative 1, or negative 1. Secant is 1 over cosine, 1 over 0. Again, that's undefined. Right? And cotangent is 1 over tangent, which is x over y. So that would be 0 over negative 1, which is 0. Okay. All right, so when you fill out the rest of this table, what you're going to get is a lot of zeros, ones, negative ones, and undefined. Okay? So that's all that your trig functions can be at these quadrantal angles. All right, let's take a look. So I want to show you guys how to do this on your graphing calculator. Say a TI-84, 83, 82 would all be similar. Okay? The first thing you need to do is make sure that your calculator is set to degrees. Okay? To do that, you're going to locate the mode button on your calculator. Okay? This is towards the top, okay, in the second column. Okay? When you hit that mode key, you want to scroll down to the third line and highlight degree and press enter. Okay? You'll notice that the other thing on that line is radians, and later on we are going to be using radians. We're going to have to use both. In fact, like most of you guys are taking this class to get prepared for calculus, and in calculus all you use is radians. Okay, so make sure that you're highlighted to degrees, okay, and then quit back to the main screen. You can do that by pressing just clear, okay? And then to type these in, you're just going to hit the sign key, which is 4 rows down in the second column. So you're going to hit sign. Sign will automatically open up a parenthesis, and you can just type in 540, and you can close the parenthesis off, okay? And you should get 0. Okay? Now, when you hit tangent of 450, okay, again, tangent's one of the buttons on your calculator. So you press tangent 450, okay, close your parenthesis, and it says go to domain. Okay. Now what does that mean? Well, what's going on there is go to domain is a domain error, and the domain error that we're talking about here is dividing by 0. Okay? And we talked about this on the previous screen, that when you divide by 0, okay, this is dividing by 0, okay, that means that you're undefined. Okay, so we would just say that this is undefined if we saw this on our calculator. All right, last one, secant of 60. Now notice on your calculator there is no secant button. So what we're going to have to do is use the fact that secant is 1 over cosine. So to type this on your calculator, you're going to do 1 divided by cosine, then type in 60 degrees, and you'll get an answer of 2. Okay. All right, so go ahead and practice that on your calculator. Since all this is an online class, if you're confused on how to use this calculator, you can always Google like how to do this on a TI-84, or if you have a Casio or HP, just Google about it. I'm sure you'll find nice screenshots. Probably get a web page on Texas Instruments help page on how to do this, a little bit more than me just trying to talk you through it. Okay. All right, last thing we want to talk about on this particular video is some notation for squaring sine. Right? So this notation, sine with a 2 here, sine squared of 30 degrees, is shorthand for sine of 30 degrees all squared. Okay? Now the reason that we write it this way is because if we write it this way, we have to use this parenthesis. Because if we don't, it's confusing on whether we're squaring 30 degrees or we're squaring all of sine. Right? So to do this on your calculator, what I would do is I'd do sine. Okay? It opens up a parenthesis automatically. Press 30, okay? And then press enter. Okay? So press sine of 30, press enter, and it gives me 0.5. Okay? Then sine squared of 30 degrees, is simply 0.5 squared, or 0.25. Okay. Alright, so I just want to make sure you know this notation. We use it quite a bit, that this square here is the same thing as sine of 30 all squared. Alright, so that concludes this video. You should be ready for your third homework set at this point. Okay? So go ahead, give that a try. Again, once again, thank you for watching.